Hi guys, welcome back. Today we're going to do just some review on solving systems using elimination. Don't forget, if you have questions, email me right away. It's definitely not too late to turn in late work for quarter 3 or quarter 4. Make sure that you have a pencil and paper and be ready to take the notes. If you haven't already done the other systems lessons prior to this one, you should stop now and go back and do those. This is going to be just some review. Be sure to use your school email address. If you haven't logged into your school email address, email me and I can help you get it figured out. From this point forward, the Google Forms IP will be locked unless you log in with your school email. There's definitely not a reason to guess, leave blanks, or write IDK in an answer blank. Email me or attend office hours to get your questions answered. Don't forget that it's really important for you to understand the material, not just make random guesses. I'm here to help and can work with you on problems that you don't understand. Don't be like this kid here and just walk over all the steps. You need to read the directions, you need to watch the video, you need to do the work on a separate sheet of paper and then submit. You can actually skip the step of taking a picture of the worksheet and attaching it. We're not doing that anymore, so you can skip that step, but you need to do the rest. Don't forget that quarter 4 is supposed to end May 21st. If you're passing with a C or better by then, you're done. If not, you'll need to continue working for an additional week. So let's get these assignments handed in. Don't forget, if you have a 60% or better, you'll be eligible for remediation at the end of the semester, and most of you can hit that mark just by handing in your missing work. Bonus point project. We'll be offering you a bonus point project for the month of May. The project will be worth 10 points and will involve you choosing from a list of specific skills and creating a presentation of your choice on that skill. We've designed this project to be possible for every student to do, and it should be a boost to your grade if you make an effort to meet the requirements. Projects will be due by midnight on Friday, May 29th. The expectations and rubric for this project can be found on the Haiku page. There will also be a second project towards the end of the semester, so keep your eye out for that one. That will also be for bonus points. My celebration this week is that last week we had a great Riley Dance Marathon Spirit Week. We've almost met our goal for our first year of having our own dance marathon, even with having to move that online and not being able to do the dance marathon itself. Follow us on Instagram at RHSRDM. All right, let's start with some review. We want to make sure that we're able to identify slope and y-intercept from a graph. So remember, B stands for our y-intercept, and we said a good way to remember that is B is your beginning point. So in this case, our B is where the line crosses the y-axis, so our B is equal to 1. If we were to write that as a point, it would be 0, 1. Now, to find the slope is the change between 2 points. So I need a second point on the graph. I'm not going to use, for example, this one because that's the point 1, like 3/4. So that one's not going to work. But I notice I could use 1, 2, 3, 1, 2, 3 right here. 3, 3 is a good one. Now that's not the slope. That's the second point. The slope is the rise, how much it goes up, divided by the run, how much it goes over. So I'm going to go up, and that goes up 2 spaces, and I went up, so that's a positive. And then I went to the right 3, that went to the right 3 spaces, so that's a positive, so that becomes 2/3 there. So my slope is 2/3, my y-intercept is 1. If I wanted to write that in slope-intercept form, I would just substitute in the slope goes in front of the x, the y-intercept goes by itself. Now equation that represents that line. We noticed you had some trouble on the last IP answering these questions. I want you to use the words to help you. What do you need to write an equation in point-slope form? It's literally right here in the equation. You need the point. When you get these kinds of questions wrong, these are the kinds of things that make me think you're maybe not watching the video or not paying attention in a way that you should be. So use that same strategy. What's needed to write an equation in slope-intercept form? Look at the word. You need the slope and you need the y-intercept. The words tell you what you need for those two equations. So for point-slope form, you're using a point and the slope. For slope-intercept form, you're using the slope and the y-intercept. All right, let's do some review on solving using elimination. So remember, the whole idea here is I have 2 equations. Both of them have 2 variables, which means I can't solve either of them by themselves. What I need to do is put them together. If one of these variables was easily isolated, like if x didn't have a variable or y didn't have a variable, I'd use substitution. But this isn't going to work because I need to use elimination to eliminate one of these numbers. Well, the goal is to get something that has the same number but opposite signs. Well, I noticed that the y's are already the same, but they're not opposite signs. So I'm going to multiply one of these equations by -1. Since equations are like a scale, everything has to get multiplied by the negative. So that becomes 2x minus 7y equals -13. The bottom one just stays the same. There's no reason to multiply it by anything because I need a negative and a positive, and that one's already a positive. By the way, I could have multiplied the bottom one by -1 instead. It doesn't matter which one you do. Now we are always adding down, so 2 plus -4 is -2. The whole idea here is -7y plus +7y cancels out. If you write a y here, that means -7 plus +7 is 1, which is not the case. The whole idea is the y's eliminate. That's why this is called elimination. -13 plus 17 is 4. So now I have -2x equals 4, which is a one-step equation. I just divide both sides by -2. The -2's cancel out, and so x is -2. But remember, my answers are always supposed to be written as a coordinate pair, an x and a y. So far I only have the x. To get the y, I can substitute into either one of these equations. The top one has numbers that are a little smaller, so I'm going to use the top one. And I'm replacing x with -2. Since the -2 and the x are right next to each other, that means to multiply. -2 times -2 is +4. Now I'm going to subtract 4 from each side. I get 7y equals 9. I'm going to divide both sides by 7, and it is perfectly okay to keep that as a fraction. It cannot be reduced. There's nothing that 9 and 7 can be divided by, and there's no reason to turn that into a mixed number. So we're going to leave our solution as -2, 9/7. All right, so we want to remember that linear systems can be solved 3 ways. Hint, hint, you should probably put these items in your notes. We can solve a system 3 ways: graphing, substitution, or elimination. When solving systems, the equations have to have like terms, so same variables. If you have an x and a y in one equation, you need an x and a y in the other equation. Using standard form for elimination is helpful. It makes sure that our x's are lined up with our x's, our y's are lined up with our y's, and our constants are lined up with our constants. The key to elimination is to get opposite coefficients. So like -2 and +2, -5x and +5x. We will use multiplication to make opposite coefficients, which is what we did in the last one. We multiplied everything by -1. And our answer will always be an ordered pair, an x and a y. Make sure you've written this stuff down in your notes. If you haven't, I'd pause the video and do that now. So let's look at another one. This time it's not as obvious which one to eliminate because I don't have any numbers that are already the same. They're already in standard form, so everything's already nice and lined up. So let's dig a little bit deeper and think about some multiples. I want to look at common multiples here. So we want to think about either common multiples for 4 and 2 or common multiples for 5 and 6. Notice that I'm not worried about signs right now. I'm just looking at the numbers in front of each variable. Well, I noticed right away that a common multiple of 4 and 2 is equal to 4 because 2 times 2 makes 4 and 4 times 1 makes 4. I would have to use much larger numbers for 5 and 6. I would have to go all the way up to 30 because 5 times 6 makes 30 and 6 times 5 makes 30. So let's not eliminate our y's, let's eliminate our x's. I want both of these to be the common multiple, and so that needs to become a 4. So I'm going to multiply everything on the bottom by 2. The top equation stays exactly the same. 4x minus 6y equals 8. The bottom equation becomes -4x plus 10y equals -20. I'm going to add down the columns. 4x and -4x cancel out because that makes 0. -6 plus +10 makes 4. And 8 plus -20 equals -12. Then we're going to divide both sides by 4. And so y equals -3. But remember, this is supposed to be a coordinate pair. I have the y, I need the x. I can use either one of these equations. I think I'm going to use that bottom one because I know that y, be careful, we're not substituting in for the x. We found the y, so the x has to stay. The y turns to a -3. So now we have -2x minus 15 equals -10. We're going to add 15 to each side. So -2x equals 5. Divide both sides by -2. And so x equals -5/2. It's okay to leave that as a fraction. 5 over 2 can't be reduced. There's no reason to change that into a mixed number as if we were trying to graph or something. All right, let's do one more together, and then you're going to try one on your own. So again, for this one, there's nothing that's obvious common multiples, but these numbers are a little smaller, so let's take a look at them. Plus, they're already opposite signs, so I wouldn't have to change the sign. So we want to think about a common multiple for 2 and 5. So we're thinking about counting by 2's. 2 becomes 2, 4, 6, 8, 10, 12. We can keep going if we need to. 5 is 5, 10, 15. Oop, I can stop because what I found is a common multiple of 10. So I want to turn both of these things into 10. This time I have to multiply both equations to make that happen. The top gets multiplied by 5, the bottom gets multiplied by 2. Everything gets multiplied, so this becomes 25x minus 10y equals 15. The bottom becomes 6x plus 10y equals 16. Let's check to make sure we accomplish what we want to accomplish. We need opposite coefficients with the same numbers, and we have that here, which means when we add, our y's are going to eliminate. 25 plus 6 is 31x. 15 plus 16 is 31. We're going to divide both sides by 31, so x becomes 1. We need an ordered pair, so we're going to use either one of the equations. I'm going to use the second one. Fewer negatives in that one. X is 1, so we're going to replace x with 1. So 3 times 1 becomes 3. We're going to subtract 3 from each side, so 5y equals 5. Divide both sides by 5, so y equals 1. So your solution there is 1, 1. All right, use this as an example. Pause the video and try that second one on your own now. I would look at maybe getting rid of the y's since they are already opposite signs. So think about making your list of multiples of 9 and 4. Welcome back. If you tried to get rid of your y's, your multiples of 4 become 4, 8, 12, 16, 20. I can keep going if I need to. Let's try the 9's. 9, 18, 27, 36. I haven't hit it yet, so let's go back to the 4's and try again. So 24, 28, 32, 36. There we go. A common multiple for 4 and 9 is 36. So in order to make 36, 4 times 9 gives me 36. 9 times 4 gives me 36. So this becomes 45x plus 36y equals negative 270. The bottom becomes 12x minus 36y. And then 18 times 4, I don't know off the top of my head, so I get out my handy dandy calculator and I get negative 72. And then we're adding. 45 plus 12 becomes 57x, cancel out. Negative 270 plus negative 72 is negative 342. We're going to divide both sides by 57, and we end up getting that x equals negative 6. So the numbers looked crazy, but our answer ended up just fine. X equals negative 6. So we go back to either one of these equations. I'm going to go with the bottom one. So we have 3. We're going to substitute negative 6 for x. 3 times negative 6 becomes negative 18. Minus 9y equals negative 18. We're going to add 18. That cancels out. We're left, which means y has to be 0. So my solution should be negative 6, 0 for that one. All right, you're going to go back to the haiku page, use these notes and office hours if necessary to complete the IP. Putting IDK or leaving blanks too many times could cause you to fail, so why don't you come on over to office hours and we can work on some of these together after you've watched the video and taken notes. Have a great day.